Good morning, algebra students, and today we divert a little bit to something we call arithmetic sequences. We teach them after we teach relations and functions because you're going to start to see these kinds of relationships show up, and also because it is a highly tested area in algebra. You'll see it on the PSAT, the SAT, and other things. So we'll start with our do now. And we're asking you to respond thoughtfully to a question about what it's like to distance learn math. It sure is something new for you this year. Our objective will be to learn about arithmetic sequences. And our essential question will ask how we can identify an arithmetic sequence, what is the common difference, and how can I use an arithmetic sequence to determine the nth term in a sequence? And we'll find out what that means. Our assignment will be to watch the video and complete 2 pages. I've also included your homework page in here. I'm going to touch on that a little bit too. Our exit ticket is to complete this sentence. The nth term of an arithmetic sequence can be found using the formula. Okay, so we've got a formula that we're going to memorize today. And we do memorize a few things in algebra, and I'll show you some tricks to do that. Our homework tonight will be homework 6, arithmetic sequences. And just remember, if you have been sent an assignment spreadsheet, let's use our Thanksgiving holiday to get caught up. Make sure you complete your unfinished work. I don't collect all the homework right away, although I do put a correction sheet on Teams, but you should do it the day it's assigned, okay? And as I've been saying for the last few days, on Thursday, December 3rd, we will have a test. So my picture for you today is just a reminder to enjoy the most thankful day of the year. It's a beautiful time. It's been a difficult year for many of us, but I know that there are so many things we can find to be thankful for, and I'm thankful for you. I'm thankful for my algebra classes. I'm thankful for the opportunity to teach algebra, and I'm thankful that even in this crazy year, we can give ourselves the gift of education and knowledge. So our do now today asks the question, is learning math easier or more difficult for you with distance learning, and why? And I can think of some disadvantages. And for me, in terms of being the teacher, I miss seeing your faces. That's why even just those few minutes at the beginning of the class on camera is important to me. But I also I miss the opportunity to walk around and see you while you work in the moment of learning, because that helps me to understand how I can help you with whatever mistakes you're making, and we can straighten them out right away before they become bad habits. So I miss that. And here is our exit ticket, where we will put the formula for finding the nth term of an arithmetic sequence. So let's get started with our lesson. And our topic today is arithmetic sequences. You can say arithmetic if you want. This is how I learned it, though. If we're talking about a sequence, we pronounce it arithmetic. So, what is an arithmetic sequence? It is a sequence in which the difference between any 2 consecutive terms is constant. And you know what a consecutive term is, right? Because we've talked about consecutive number problems. So let's write this down. A sequence in which the difference, so we've got some subtracting in mind, but not always, you'll see. The difference between any 2 consecutive terms. I didn't say consecutive numbers this time. I said consecutive terms. Is constant, and that word constant, it is the same. Okay, now what is the common difference? So the common difference is the numerical difference between any two consecutive terms, and we represent that with the letter D. So the numerical difference D, okay? Between any two consecutive terms. Now remember, consecutive terms, if they're not defined otherwise, are one right after the other. But if we define them otherwise, they can be consecutive odd terms, consecutive even terms, or even defined some other way. They can even be defined with subtraction. And we're going to see that. So let's look at an arithmetic sequence and let's try to identify them. So if I've got, we're going to use D equals to do that. So we're going to look at these terms and then we're going to see, is there something common that's constant, unchanging, that's happening between each value? So what's happening? What do I do to get from 1 to 5? And what I do is I add 4. How do I get from 5 to 9? I add 4. From 9 to 13, I add 4. Okay, definitely this is an arithmetic sequence. So what is the common difference? The common difference, D equals 4. Now, how do I get from 1 to 3? I add 2. 3 to 5, I add 2. From 5 to 8, I add 3. Sorry, no common difference, okay? So it's not an arithmetic sequence. Remember, we're asking, is this an arithmetic sequence? So 8 to 6, I subtract 2. 6 to 4, I subtract 2. 4 to 2, I subtract 2. So, excuse me, is there a common difference? Yes. And what is our D? Well, each time we're subtracting 2. So our D equals minus 2. And what am I doing? From negative 5 to negative 8, I'm subtracting 3. Negative 8 to negative 11, I subtract 3. And negative 11 to negative 14, I subtract 3. So yes, I do have a common difference. And for each value, I have subtracted 3. So our common difference, our D equals negative 3. Let's write that a little more neatly. And let's look at number 5. I've added 5 to get to 10, then I've added 10, and then I've added 20. Not a common difference. So simply no, not an arithmetic sequence because there's no common difference between those values. And let's look here. We're subtracting 1, 6 to 5, subtract 1, 5 to 4, subtract 1. So yes, we have an arithmetic sequence and the common difference is subtracting 1. So you get the idea, and in your homework, in the first 6 problems, you'll be doing the exact same thing. You will just be looking to see, is there a common difference? So I can do the first one with you. 4 to 7, we add 3. 7 to 9, we add 2. 9 to 12, we add 3. Not a common difference, so it's not an arithmetic sequence. And you just go through that process for each one of them. So now we're continuing arithmetic sequences that have been given to us. So given the arithmetic sequence, we're going to find the next 3 terms. So these are all already a yes. We know they are already arithmetic sequences. So what's happening between 9 and 13? It looks like we're adding 4. 13 plus 4 is 17. 17 plus 4 is 21. 21 plus 4 is 25. 25 plus 4 is 29. 29 plus 4 is 33. Let's go on to number 8. So, what do we do to get from 5 to 2? We subtract 3. To go from 2 to negative 1, we subtract 3. Draw a number line for yourself if you're having a little trouble with this. To get from negative 1 to negative 4, we subtract 3. So if we subtract 3 from negative 4, we would have negative 7. If we subtract another 3, we would have negative 10. If we subtract another 3, we would have a negative 13. So go ahead and try the next one. Try them on your own before you watch me do them. Okay, so what's happening between negative 8 and negative 2? We're adding 6, negative 2 to 4. We're adding 6 and 4 to 10. We're adding 6. 10 plus 6, 16, plus 6 more, 22, plus 6 more, 28. And if you look at your homework, you're doing the same thing for the next group from 7 through 10. So 3 to 7, we're adding 4. 7 to 11, adding 4. 11 to 15, we're adding 4. So 15 plus 4, 19, plus 4 more, 23, plus 4 more, 27. Let's go back to our lesson. Okay, now here's the heart of the lesson. We are now at the arithmetic sequence formula. And students, I want you to commit this to memory, and I'll help you do that. So the nth term, what does nth mean? Nth means the number that I want to find. The nth term of an arithmetic sequence can be found using the following formula. A sub n equals D times the quantity of n minus 1 plus A sub 1. What does this all mean? Okay. D means the common difference. So the common difference is this amount. And if we look back up here to number 9, this 6 that we added, that was the common difference. If we look at number 8, the common difference was negative 3. So the common difference will be different in each problem. The A sub 1 is the first term in the sequence. So let's look at some notes that I've made. So the nth term, I'll highlight as I go, of an arithmetic sequence can be found using the following formula. And here we are. A sub n equals D, common difference, times the quantity, and we have these parentheses, we use this language, quantity times the quantity of n minus 1 plus A sub 1. And what do these all mean? Our D is the common difference. Our A sub 1 is the first term in the sequence. So let's look at this a little bit more closely. And if you want to screenshot this while we're working, I think that's a great idea on your phone. So what does this N mean? N means the term that I want to find. So let's take this apart, this A to sub N. When we say it like that, sub N. So when we say A sub N, we are saying to find the number in an arithmetic sequence. That's our A sub N. Equals, or we must, D multiply the common difference by the quantity of the term you want to find minus 1, and that's our n minus 1, and then add it to the first term in this sequence. Let's review that again. To find the number in an arithmetic sequence. That's what this means, a sub n. So to find the number in an arithmetic sequence, that's our a sub n. We must multiply the common difference. That's the d. Oops, should have put that. Sorry, I meant to write that right here. It's our d. Multiply the common difference. Now, by the quantity of the term you want to find minus 1, okay, by the quantity, it's all color-coded, of the term you want to find minus 1, and add it to the first term. Here it is, add it to the first term, plus a sub 1. Okay, so let's write it all out. To find the quantity in an arithmetic sequence, you must multiply the common difference by the number you want to find minus 1, and that's a quantity, added to the first term. So a sub n equals d times the quantity of n minus 1 plus a sub 1. A sub n equals d times the quantity of n minus 1 plus a sub 1. Okay, so let's do some erasing. A sub 1 equals d times the quantity of n minus 1 plus a sub 1. A sub n equals d times the quantity of n minus 1 plus, cancel that, plus a sub 1. A sub n equals d times the quantity of n minus 1 plus a sub 1. Now, can you remember it all by heart? A sub n equals d times the quantity of n minus 1 plus a sub 1. Now, can you write it on your own? A sub n equals d times the quantity of n minus 1 plus a sub 1. So let's go back to our lesson where we're actually going to apply this. So now for our examples, we're asked to write the rule for the nth term. The nth term is the term we want to find. And then we're going to find the 19th term in the sequence, a sub. So this is our a sub n, but we've defined n as 19, okay? So we want to find a sub n. Now we also need to define our first term. So a sub 1 is the first term here, 7. And we need to define our common difference, d. And our d, let's see, 7 to 13, we add 6. 13 to 19, we add 6. 19 to 25, we add 6. So our d is 6. So now we can write our, I'm going to change my color. Now we can go ahead and write our formula. So a to the n equals 6. 6 is our common difference, times the quantity of n minus 1 plus the first term, which is 7. Now, when you write these out, you always need to distribute. So let's go ahead and distribute the 6 over n minus 1, and then you'll need to combine like terms. So 6 times n is 6n. 6 times negative 7 is negative 6, plus 7. Now we need to combine like terms. Negative 6 plus 7 is 1. And this is the rule. Okay, so we've taken care of the first part. We've written the rule for the nth term in this sequence. Okay, now we're going to find the 19th term. So this is really a second problem here. So to find the 19th term, a sub 19 equals, you just copy this, 6. We're substituting with parentheses. I hope I've built that habit into you. Plus 1. And then we just evaluate that. 6 times 19 plus 1 equals 115. So instead of writing out this whole sequence, 7, 13, 19, 25, 31, 37, okay? Instead of writing out this sequence until we got to the 19th term, we just used this formula. Which is much quicker. So this was a two-part problem. We had to find the rule, and we had to find the 19th term, and we've done that. So let's look at the next one. First, we have to find our first term, our a sub 1, and our first term is 30. And then we have to find our common difference. So let's look at this. 30, 26, well, it looks like we're subtracting 4. 22, we're subtracting 4, subtracting 4. So we're subtracting 4. So let's build our rule. A sub n equals, oops, I should have written 4, not 6, equals negative 4, okay, because the common difference can be negative. Negative 4 times the quantity of n minus 1 plus 30. And let's distribute. So we have negative 4 times n, negative 4n. Negative times a negative is a positive, plus 30. And now we combine like terms. So we have negative 4n plus 34. And that's the rule. We did, the first part was write the rule. So now we're going to find the 19th term. So a sub 19 equals negative 4. It's simply a substitution. Times 19 plus 34. And negative 4 times 19 plus 34 equals negative 42. So that's our 19th term. So first thing we need to find, do you want to try a few on their own? That would be great if you tried them on your own and then came back to the video. Okay, so number 12, we have to find our first term and our common difference. Our first term is negative 11. Our common difference, it looks like we are adding 3 between each one of these. So our common difference is 3. So let's create our rule. A sub n equals 3 times the quantity of n minus 1 plus the first term. Well, the first term is negative 11 minus 11. So there's our first term right there. So let's evaluate that. 3n minus 3 minus 11. Let's combine those like terms. 3n minus 14. So here's our rule. And let's find the 19th term. So a sub 19 equals 3, substitute 19 minus 14. 3 times 19 minus 14 equals 43. Number 13, our first term, our a sub 1 equals -2. And it looks like we're adding 2 between each term. So our difference, common difference, is 2. So let's build our rule. A sub 1 equals our common difference, 2 times the quantity of n minus 1 plus the first term, which is -2. So I'm going to erase the plus and just write -2. And then I'll distribute, which will give me 2n minus 2 minus 2. Then I'll combine like terms, 2n minus 4. Here's our rule. Let's find the 19th term. So a sub 19 equals 2 times the quantity of 19 minus 4, which we evaluate to be 34. Let's change our color a little bit. Okay, number 14, our first term, our a sub 1. Let me write that a little more neatly. Our a sub 1 is -16, and our common difference looks like -16 and -21. We're subtracting 5, -21 to -26. We subtract 5, -26 to -31. We subtract 5. So our common difference is -5. Let's build our rule. A sub n equals -5 times the quantity of n minus 1, that's part of the formula, plus the first term, which is -16. Now we'll distribute. So we have -5n plus 5, because a negative times a negative is a positive, minus 16. Now we'll combine those two like terms, and we'll end up with a rule of -5n minus 11. So there's our rule. And now we will find the 19th term. A sub 19 equals -5. Our n is 19. We want to find the 19th term. And when we evaluate -5 times 19 and subtract 11, we have a -106. So that would be the 19th term in that sequence. And number 15, our first term is 101. And our common difference, so what's happening here, looks like we are subtracting 9 between each one of these. So our common difference is -9. Let's build our rule. A to the n equals -9 times the quantity of n minus 1. And then we add our common difference, which is -9. So let's distribute -9n. -9 times -1 is +9 minus, oh, did I make a mistake? I did. I added the common difference. I should have added the first term. Sorry about that. That should be a +101. Okay, we're adding the first term here. Sorry about that. So plus 101. Now we need to combine the 9 and the 101. So -9n plus 110. That's our rule. Be careful of that negative there in the beginning. So let's go ahead and find the 19th term in the sequence. So we have -9. Our n is now substituted for 19 plus 110. We multiply -9 times 19 and add 110. Our final answer is -61. So you can get some pretty complicated terms, that would be very difficult to do by hand or even with a calculator, just by using the formula. The formula really helps us with a shortcut. You've got a couple of these in your homework as well. So let's do one of those. Let's look at number 11. So our first term is 1. Our common difference, we're adding 2. Common difference is 2. So let's find a rule. A to the n equals 2 times the quantity of n minus 1 plus 1, and we'll distribute 2n minus 2 plus 1. We'll combine like terms, and that's our rule. And then let's find our 19th term. A to the 19 equals 2. Actually, we're not finding the 19th term, we're finding the 24th term. Times 24, so we substitute a 24 there, minus 1, and 2 times 24 is 48, minus 1 is 47. So remember, we're finding the 24th term here for your homework. So I gave you a little bit of a head start here. Let's look at some applications, and we're almost done. So in our first one, you visit the Grand Canyon and drop a penny off the edge of the cliff. The distance of the penny that the penny will fall is, for the first second, it's going to fall 16 feet. For the second second, it's going to fall 48 feet. And for the third second, it's going to fall 80 feet. So it's going to fall much more quickly as it goes down. So maybe if this is the Grand Canyon and you drop a penny off here, in the first second it will go 16 feet, then 48 feet, and then 80 feet. And as it goes down further and further and further, it's going to go faster and faster and faster until it hits the ground. That is the acceleration of speed there. So we've got a sequence, and the sequence is 16, 48, 80. So first we're asked to write a formula to represent the sequence, and then we're given an nth term, okay, of 6 seconds. That's going to be our nth term. So first thing we need to figure out is the common difference, okay? This thing is accelerating. So from 16 to 48 is an addition of 32. From 48 to 80 is an addition of 32. So we have a first term of 16. So our A sub 1 is 16. Our common difference is 32. So first we're going to write the formula, which is the same as writing the rule. So A sub 1 equals 32, okay, our common difference, times the quantity of n minus 1 plus the first term, which is 16. Let's distribute and then combine like terms. So 32n minus 32 plus 16. Now we'll combine like terms. 32n minus 16. And that's our rule, or our formula. We can call that the rule. We can also call that a formula. Now we need to find the 6th term in the sequence. How far will this penny have gone after 6 seconds? So a sub 6 equals 32. We substitute n for 6 minus 16. And 32 times 6 minus 16 is 176. Let's go back. Our unit of measure, we go back to the problem, is feet. So let's include that in our answer. So after 6 seconds, the penny will have traveled 176 feet. So now we've got a money problem. I love these money problems. The total bank loan for Sarah's new car is $15,265. The bank automatically withdraws $295.80 a month to pay off the car. She's on automatic withdrawal. You will often get a discount for that, students. If they don't offer it to you when you get your car loan, ask for it. I get a discount of $5 a month on my cell phone bill because I do automatic withdrawal. That adds up at the end of the year. That's $60 a year I'm spending because I have that automatic withdrawal. So building good money habits is an important part of learning mathematics in high school. So now be very careful with these problems. This is a withdrawal. Because it is a withdrawal, we're going to take this common difference and we're going to make it a negative. So our first term, and this is another thing that you have to be careful about. So let's think about that. The first term, okay, we need to take 15,265 and we need to subtract $295.80. And we will get $14,969.20. Okay, so this is our first term. Our a sub 1 equals $14,969.20. Our common difference is we're taking $295.80 out each month, so it's a negative $295.80. Finally, as we work this problem, we don't need these zeros, okay? Because they each end in a zero. I can go ahead and remove that zero. If you keep the zero there, it's fine. But I just wanted to show you as a matter of practice in algebra, if we have a final zero, we can go ahead and just eliminate it because we haven't changed the value of that number. So let's go ahead and figure out the formula to represent the sequence. So we have a sub n equals, now we need our d, our negative 295.8, times n minus 1 plus the first term, which is our 14,969.2. Now let's go ahead and distribute first, then combine like terms. So negative 295.8n, negative times a negative is a positive, so plus 295.8 plus our first term, 14,969.2. Now we can combine these two terms, so we add them together. So we've got negative 295.8n plus 15,265. And this is our formula or our rule. Now, we want to find the balance after 2 years. This amount was given to us in months. So we need to convert the 2 years to months, which is 24 months. That's very important or you won't get the right answer. So A sub 24 equals, we go back to our rule, negative 295.8 n, and our n is 24 months, plus 15,265. It's a comma. So we combine like terms and we add. So we're going to multiply 295.8 times 24 and add 15,265. And when we do that, our final answer is $8,165.80. Now, because this is a final answer, I'm going to put the dollar sign and I'm putting the zero back because we use a number system that has 100 pennies to the dollar. So after 2 years, Sarah will still owe $8,165.80 on that car. Let's look at your homework again. Let's look at Charlie. Charlie deposited $115 in a savings account. Each week thereafter, he deposits $35 into the account. Let's write a formula to represent the sequence. So he starts out with $115. So our A sub 1, so he deposited $115 and then he deposits $35. So our A sub 1 is 115 plus 35, which is 150. And our common difference is 35 because he's depositing 35 per week. It's a good start to his savings. Let's write our rule. A sub n equals 35 times the quantity of n minus 1 plus 150. And so that would be combine or distribute first, 35n minus 35 plus 150 would give us 35n plus 115. That's our formula. Now we want to know how much he is deposited after 30 weeks. So A sub 30 equals 35. I'm just taking the formula right from here. I'm substituting n for 30 plus 115. And 35 times 30 plus 115 is $1,165. Guys, for only $30 a week, Charlie has, for $35 a week, in just 30 weeks, not even way less than a year, he's already socked away $1,165. So he's on a roll there. Good for Charlie. Okay, so let's go back to our exit ticket, and then we're done for today. So complete this sentence. The nth term of an arithmetic sequence can be found using the formula. I hope you know it by heart by now. A sub n equals d times the quantity of n minus 1 plus the first term, A1. Congratulations, we've now done arithmetic sequences. You've worked hard. Please use the 5-day holiday to catch up on anything and start studying for that December 3rd test in algebra. You guys have done a great job, and I am thankful for you. So keep up the good work, and with practice, you'll be great.